today we're going to be looking at writing rules for patterns using variables. So the first pattern we have here is made with linking cubes. This is stage 1, and this is stage 2, and this is stage 3. So if I wanted to look at stage 4, I could say that I'm going to have, in stage 1, I have 2 red and 2 blue. In stage 2, I have 2 red and 4 blue. And in stage 3, I have 2 red and 6 blue. So my guess is that stage 4, if it were to continue this pattern, would be 2 red and 8 blue. Now that I can see how my pattern is developing and I understand what's happening from stage to stage, we need to talk about setting this up in a number format, in a function table. So I'm going to take and I'm going to create a function table for this, and we're going to make the input be n, which is the stage number, and I'm going to make the output be the number of blue cubes in that stage. So in stage 1, we have 2 blue cubes. In stage 2, 1, 2, 3, 4. And in stage 3, we have 1, 2, 3, 4, 5, 6 blue cubes. And in stage 4, we have 1, 2, 3, 4, 5, 6, 7, 8 blue cubes. Now, when I write my rule, I want it to be based on how my pattern grows from the stage number to the number of blue cubes. Because what I want to be able to do at some point is say, hey, how many blue cubes are in stage 52? But I don't want to have to go and do every other stage from here to 52 to get my answer, because I can see obviously these numbers are going up by 2, but I really don't want to have to figure all that out and count it all through. So what we're going to do is look at the rule in a different way. So we're going to say, how can we get from stage 1 to 2 blue cubes? Now, mathematically speaking, there aren't a lot of choices. I could add 1 to 1, or I could multiply by 2. As I look, I'm going to check my plus 1 rule first. So 1 plus 1 is 2, but 2 plus 1 is not 3, and 3 plus 1 is not 6. So it doesn't seem like that can be the rule. So let's try times 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. So my times 2 rule seems to work, but I don't want to just write times 2. I want to say that my total number of blue cubes is equal to the stage number times 2. Now that looks nice and simple, but algebraically, as we talked before, we don't like multiplication signs. So what we would prefer to do would be to write this rule as b is equal to 2 times n, with no symbols in between. When we write expressions and equations in algebra, whenever you have a number next to a letter, the number almost always goes first. So the rule for getting from the stage number to the number of blue cubes is simply 2 times the stage number. So that means if I wanted to find the number of blue cubes in stage 52, all I have to do is double it. So I would write blue is equal to 2 times 52, so blue is equal to 104. And I could fill in my table. So that way I don't have to do stages 5 to 51 to figure this out. Because let's face it, that doesn't sound like fun. Okay? We can also look at how many total cubes there are. So we're going to do n is equal to the stage number again. And then we're going to make the output equal to t for the total cubes. So as I'm doing this, I'm again going to have stages 1, 2, 3, and 4, but now I'm going to include my 2 red cubes as well. So we have 2 red and 2 blue is 4, 2 red and 4 blue is 6, 2 red and 6 blue is 8, and 2 red and 8 blue is 10. So I still have stages 1, 2, 3, and 4, but now I'm looking a little bit different. And again, I'm going to want to write this rule so that I can get from my stage numbers to my total number of cubes in case I want to find, say, stage 38. Okay? So I'm going to try the simple rules first because it worked really well with the first pattern that we did, so maybe it'll be a simple one again. To get from 1 to 4, I could do plus 3. I could also do times 4. So we're just going to look at plus 3 first. 1 plus 3 is 4. 2 plus 3 is not 6 though, and 3 plus 3 is definitely not 8, and 4 plus 3 is not, or 4 plus 3 is definitely not 10. So that's not it. So let's look at times 4. 1 times 4 is 4, but 2 times 4 is not 6, and 3 times 4 is not 8, and 4 times 4 is definitely not 10. Now, there's a trick when we know that it's not a plus or a basic multiplication. There's a trick. I said before that to get from here to here, it was just plus 2. And from here to here, it was plus 2. And here to here, it was plus 2. Well, this really cool thing happens when you're working with these kinds of patterns. It turns out that this number that you're adding here, to go from here to here to here, if it's not a basic addition or a basic multiplication, this number is what we're actually going to be multiplying the stage number by. So we're going to do the stage number times 2, but I have a feeling we're probably going to have to do something more as well. So if I do 1 times 2, I don't get 4, I get 2. But to get from 2 to 4, I could do plus 2. Let's see. 1 times 2 is 2. Let's check this. 1 times 2 is 2, plus 2 is 4. Oh, that's right. Let's see. For stage 2, we would do 2 times 2 plus 2. And 2 times 2 is 4, plus 2 is 6. Ooh, this is looking really good. So then 2 times stage 3 plus 2. 2 times 3 is 6, plus 2 is 8. Oh, I think we may have found it. Let's just double check stage 4. 2 times 4 plus 2. So 2 times the stage number is 8, and that equals 10. Oh, look, we found it. So I want to take my rule, and of course I don't want to leave an expression. I want to make it a complete equation. So the total number of cubes is equal to 2 times the stage number plus 2. And that's the method I can use to find my rule. So again, in this second case, we tried plus 3, but that didn't work. We tried times 4, but that didn't work. So then we recognize that the distance between these is going to be what we're multiplying by. And then we figured out what we had to add or possibly even subtract to get to the next number. Now there is one other pattern that I can think of that we could have done here, and that would be the total number of red cubes in each stage. So if I do that with n equaling the stage number and r equaling the number of red cubes, stage 1 has 2, and stage 2 has 2, and stage 3 has 2, and stage 4 has 2. So it looks like this rule is really, really simple. This rule would be that the number of red is equal to 2. It doesn't matter what stage it is, it's not changing. So again, just to review what we did, we took our pattern, We translated it into a function table by looking at the stage number and another variable, like the number of blue cubes, the number of red cubes, or even the total number of cubes. And then we went from our stage number to our output to find our pattern. And remember, this one, I didn't write it on this paper, was 2n plus 2. And this was blue is equal to 2n. So we found our three different rules, and notice that again we could take and we could find any stage number we wanted for those rules. And that's the goal of this lesson.